My dear students, so today we'll talk about the velocity of the particle performing simple harmonic motion. Right, let's start. Suppose one particle is performing simple harmonic motion about this mean position when x is equal to 0, okay, and here x is equal to plus a and x is equal to minus a, and here it is performing simple harmonic motion. Right? Now we have to find the expression for velocity of the particle performing this SHM. Acceleration of this motion is given by minus omega square x. This is what? The acceleration of SHM. Okay? Now we know that acceleration is dv by dt. Correct or not? Acceleration is dv by dt. Now this acceleration can be written as, if I will write dx divided by dx, then there is no effect on this. Alright? So, but I'm getting, look, dx by dt is a velocity, dx by dt is a velocity, and dv by dx I can write here. So this is a what? Expression for acceleration. Let us take this dx on this side. A into dx is equal to v into dv. Okay. Now what we will do? We will integrate this equation. So integrating on both sides, what you will get? A dx is equal to integration of v into dv. Now let us put the value of acceleration here. What you will get? Integration of, what is the acceleration here? Minus omega square x dx is equal to integration of v dv. Correct or not? No, let us integrate this. So this minus omega square can be taken outside. So minus omega square integration of x dx is equal to integration of v dv. Any problem? Okay. Now look. This minus omega square, integration of x is what? X square by 2 is equal to integration of v with respect to dv is what? V square by 2 with respect to. Correct or not? Plus c we have to write. If you are not applying limits, so we have to write c, indefinite integral. Okay. Now let us say this is the equation number 1. What we will see? We have to calculate value of c. How to calculate? So we know that particle starts moving from this point, let us say, it will go here, velocity becomes 0 at this place. It will stay there and it will come back, again it will go there. So at extreme position, velocity is 0. Okay, now that is fixed. If this velocity is not 0, particle will go beyond, no. It will not come back. Velocity is becoming 0 and then it is coming in this side because acceleration is negative. Okay, opposite to this motion. So that is why body is coming back. Means velocity at this point must be 0. That is fixed, final. Now, so at x is equal to a, velocity is surely 0. Correct or not? Let us put these values in this equation 1. So minus omega square x is a square by 2 is equal to v square by 2 plus velocity will be 0 at this place. When if you are putting x is equal to a, velocity must be 0. 0 square 0 plus c. So this is 0. So c is equal to what then? C is equal to minus omega square a square by 2. Correct or not? Now this value of c you put there. Minus omega square x square by 2 is equal to v square by 2 plus what is c? C is minus omega square a square divided by 2. Correct or not? Now this minus you take on this side, or this value you take on this side. So what you will do? This you will take on this side. So this minus value will become plus on this side. This will become omega square a square by 2. This minus value minus omega square x square will remain here. And what remains on this side? V square by 2. So this is equal to, so what I can write here, omega square x square is equal to V square by 2. Correct or not? Let us simplify this. 2 here, 2 here, 2 here. So 2 you can take common and cancel. So finally what you will get? Omega square. This 2 get cancels. This omega square I can take out. So a square minus what remains here? What remains here? X square is equal to V square. So this V square, V is equal to root of this. Root has two values. One is positive, one is negative. So plus or minus root of this square, taking square root on both sides. So root of omega square is omega, and this will be a square minus x square. So this is the expression for general expression for velocity of the particle performing simple harmonic motion. Correct or not? Now let us see three different cases. Already we know v is equal to 0, v is equal to 0 at extreme position. From this equation also we can get this. At this place x is equal to a, if you put x is equal to a here, this will become a square minus a square 0. So at extreme position velocity 0. On that side also x is equal to what? X is equal to minus a here. This is equal to minus a here. So minus a square will be a square. So a square minus a square again 0. Though it is minus a, it is a square, no? So minus a square is plus a square minus a square 0. Again that will be 0. And in general anywhere, suppose particle is coming here, this value of x we can put and you can get the velocity at that place. Correct or not? Now when particle is at mean position, x is equal to 0. So this x is equal to 0. So it will become omega under root a square minus 0. So omega under root a square. Okay. Under root a square is a. So omega a. So here velocity will be maximum at mean position. That value is plus or minus omega a. Now look. Plus means particle is going on that side. That will be plus a. If particle is going on this side, direction changes. So that we have to take negative. Value will be omega a. But direction. Minus sign indicates direction. So in this direction if it is going, okay. So once go here, again go on this side. So this at mean position velocity will become maximum. That is omega a. Okay. So 2 times the particle is coming at mean position in one cycle. Correct or not? Once, twice. So in this way we can derive the expression for this. So in the next video we will derive the expression for velocity, again for the velocity in terms of time. Here in terms of x displacement we have derived. Now in the next video we will derive the expression for velocity in terms of time. Okay, what is the relation between time and velocity? Here relation between velocity and displacement we have derived. This formula indicates what? Gives the relation between v and x. Okay, so stay tuned, like, share, subscribe this YouTube channel. Okay, I will upload all the derivations, all the concepts on this video. Sometimes we can solve the questions based on these concepts also. Okay, so stay tuned, study well. Thank you. Goodbye.